Good morning, everyone. You're very welcome to our Trane Roundtable. We're very excited to have you all here. I'd like to let you know that the event is being recorded this morning, so for anyone who hasn't been able to join, or if you'd like to look at it afterwards, you will be able to view the recording. So my name is Geraldine Vellner. I'm the communications leader at Trane Technologies for our two businesses in Europe. And to get us started, as some other people are joining the event, I'm just going to share the introduction with you. So just bear with me as I get that started. Okay, so hopefully you were able to share that little snippet and see that little snippet of our introduction. So to start with, I want to introduce to you our two hosts who are leading the event today, and also the speakers that are with us. So firstly, we have Jose La Loggia, and he's the president of our Trane Commercial HVAC business in Europe, Middle East and Africa. And as Trane, we go to market as Trane and ICS and Thermocold in the region for Trane Technologies PLC, and later Jose will give you a bit of background to our company and the history, which goes back many, many years. In Jose's role, he has full responsibility for the strategy, for innovation and new product development, and the performance of the commercial HVAC business. He joined the company in 1994 in Australia and has served in many leadership roles within our business. His leadership has been instrumental in establishing and growing partnerships with customers and suppliers and partners, and which led to the acquisition of Thermocold in 2017 in Bari in Italy, and also to ICS Cool Energy in 2018. In 2018, Jose was a finalist for the company's most prestigious award for leadership, and he graduated from the University of Sydney with a bachelor's degree in mechanical engineering. He also regularly features at events on sustainability and most recently appeared at the World Climate Forum in Europe just last year. So our second host this morning, we're very happy to have with us Thomas Nowak, the Secretary General for the European Heat Pump Association. Thomas is a long-term renewable energy aficionado, apart from closely following the energy transition both in the electricity and heating sectors. He's the owner of a heat pump, a PV power plant and a building in which both cooperate peacefully, according to Thomas. He'll tell you more about that, his background, when he introduces himself. But yeah, really happy to have Thomas here. They're a great partner with us, the European Heat Pump Association, and I'm sure Jose will also reference that when he speaks. So delighted to have you here. I will pass over to Jose in a few moments, but before I do that, I just briefly want to introduce also the speakers that we have with us this morning. We have Jeroen Roos, who's representing the Aalsmeer Hub, a project in the Netherlands, and partner at Infinitus. He's been working professionally in the field of energy saving and sustainable energy since the early 1990s. And later we'll hear all about the project that he worked on with a team of other organizations in the Netherlands. Specifically, the project aim was to create heat in exchange for cold and residual heat from the local data center as a source of heat for nearby public utility buildings in Aalsmeer, the Netherlands. The project included 4 partners: a data center, a school, a swimming pool, and a plant company. We'll also have Donald McBrain, who's the business development manager at Scottish Water Horizons. And we'll hear about a really interesting project that Donald and his team worked together with Trane on, where they were able to create heat from wastewater. And again, more will be told during the project on that. And then after Donald, I'd like to introduce to you Raymond Tabona, who is from the Mater Dei Hospital in Malta. And again, a really interesting project where he'll share about heat recovery and an integrated approach to heating, ventilation, HVAC plant with domestic hot water and dehumidification. So more to come from Malta very soon. And our fourth speaker, and last but by no means least, is Valerio Mcalley. And Valerio actually works for our Trane business here in Europe. He's equipment sales leader, and he'll share with us today the project that his team led at the Excelsior Hotel Rapallo in Italy. We do also have a member of the family who owned the hotel with us this morning, Guillermo, and we'll be introducing him later, Guillermo Cometto. So with that, I'm going to pass over to Jose and introduce our event. Thank you, Jose.
Thank you, Geraldine, for such a great introduction, and thank you all the panelists for joining us this morning. I know it takes a lot of time to be involved in this, and I really appreciate your energy to do it. So maybe I'll say a few words about Trane Technologies. Trane Technologies is a pure-play HVAC company that was formed 1 year ago. However, it's a company that has a huge tradition, especially around the brands of Trane and Thermo King. When you combine the experience of these two brands, they have over 200 years of experience in HVAC and transport refrigeration. So, if we think about what's going on in the world today, climate change is one of the biggest, let's say, topics that exists for majority of people. And in Europe, in particular, it's probably the #1 topic. So that's where, a company like ours, where sustainability is at the core of everything we do, can really help through the servicing our customers and with our employees, our 40,000 employees that we have around the world, to try to, deal with this problem. So we have you can imagine that is quite dealing with climate change is quite an ambitious goal. And, we have some very ambitious targets within Trane Technologies. What we really want to do at Trane Technologies is challenge an industry. And when I say challenge an industry, I mean challenge the HVAC and transport refrigeration industry in a way that we can change that industry to start to solve this problem or contribute to solve this problem of climate change. So in order to do that, we have many initiatives that we do, but we want to also lead by example. So I'll give an example of one of the things that we have done. It's a very, let's say, simple way of summarizing how we want to challenge ourselves and not just our industry. We set about in what we call the Gigaton Challenge. So the Gigaton Challenge is that we have committed as an enterprise to reduce the CO2 emissions of our customers by 1 gigaton by the year 2030. So a lot of people ask, what is a gigaton? A gigaton is quite a lot. I'm not going to say how many elephants it is, but I'll say that 1 gigaton of CO2 emissions represents 2% of the total emissions of the whole planet, and they represent the yearly emissions of 3 countries, European countries, the UK, France, and Italy. So it's quite a lot. So you'll hear today through some of the speakers that we've here today to show their leadership in trying to solve this climate change problem, how they are contributing to CO2 reductions and helping us achieve, as Trane Technologies, the Gigaton Challenge. So we know that heating and cooling is a vital part of keeping our economy running. Heating and cooling and transport refrigeration, these are things that are required to keep people comfortable, to keep people safe, to ensure the food supply chain and many other things to keep factory processes running. So really what we want to do is we want to make that, this process of heating and cooling and transport refrigeration in a much more environmentally friendly way. And if we think about solving the problem of climate change, the thing that needs to be done is that we need to decarbonize our economies. I think a lot of countries speak about decarbonizing the economy. And I think decarbonization is something that is very, I would say, well understood to most people when they think about renewable energy grids. So, producing electricity with either wind or solar, and more recently, I think people have really started to resonate with decarbonization around transportation. So we all know that companies like Tesla and some others are having great success in electrifying vehicle, the cars we drive every day. So these are things that are fairly well understood. But in our space, when we think about heating in particular, the majority of heating is done by burning fossil fuels. So if we want to decarbonize, we need to stop burning fossil fuels. I think we understand that's the case for power. We understand that's the case for transportation. And I hope that an event like this can help us all continue to promote that we also need to stop burning fossil fuels for heating. And there is another way, and that way is heat pumps. And you could think of a heat pump as the heat pump is to the boiler what the electric car is to the car with an internal combustion engine. So with that, I'm going to introduce Thomas here with a quick question. We want to challenge our own industry here, and I guess in your role as the European Heat Pump Association leader, you're also trying to challenge Europe to do this change. How do you see this energy transition going ahead, Thomas?
Yeah, thank you, Jose. I think you said it all already. I can just give in from a different perspective. Thank you for having me. Thank you also, Geraldine and the team for organizing, and welcome to more than 200 participants now. I think it's an important topic, and the way we try to challenge people, challenge policymakers at the moment is to show what's possible. Of course, in a lobby organization, in an industry association, we do a lot of work when it comes to providing the details to proper legislation. But the main thing that we have to convince people of is that heat pumps do work. The technology has developed pretty much unattended by political scrutiny for quite a few years, but now we can say heat pumps are ready. We see that in Europe, we have around 14.8 million units installed. It's about an annual sales volume of 1.5 million. One of them is mine, as Geraldine pointed out so nicely. It works very well for 5 years now. And the market is growing very strongly. We see 6 years of double-digit growth. We see an increasing interest from companies like yours that are coming in on the high-capacity side of things. But these are probably also the more fruitful projects when it comes to closing energy cycles, because you quite often have a joint heating and cooling demand, as we will see in most of the 4 projects that we look at today. We can say that we have actually challenged policymakers quite successfully over the last 10 years, because today heat pump technology is recognized in all pieces of legislation for its contribution to energy efficiency, for the use of renewable energy, and for making buildings and industrial processes more efficient. And industrial processes, I think that is the topic that we should focus on more, and that's where we started to cooperate, and I think have done so quite successfully, because that's the topic where we have an ambitious goal, but the contribution is not at the same level as in residential buildings. And now that's what I would say is the main challenge that we are facing today. The European Commission has, in its last communication on the sector integration strategy, put forward a goal of 40% of all residential buildings and 65% of all commercial buildings to be heated by electricity. And if energy efficiency first prevails, this means this will be heat pumps. So that is a number of between 48 and 50, maybe even 60 million heat pumps that have to be in place by 2030. And as I said, we have 13.8 today. So it's a factor of 4 in 10 years. And now you, as a seasoned manager, you will know that this is by no means an easy task. It's a good news for all of us, but it also means that we have to wrap up our sleeves and work really hard. And we have to convince in the end user that the technology works. And in order for the end user to be more convinced, we also need a level playing field when it comes to costs. So I would conclude with the 3 challenges that we see. We are still seeing that energy taxation is favoring fossil fuels over electricity. That's something we have to solve on the political level. We see that fossil fuels are still subsidized, and we see that we are still not having a fossil fuel tariff. And I would be very interested to hear also from the presenters how the economics of their projects were setting heat pumps versus the incumbent, maybe CHP or other fossil-based technology, and if some of them maybe even decided in favor of the environment despite smaller or bigger cost disadvantage, because that's the message that we want to give to policymakers. If we have a technology that is paying into all the energy and climate goals, it has to be the technology that is ideally the cheapest, so that the end user is also enticed to use it on economic terms. And then I'm looking very much forward to hearing to the 4 presentations.
Thank you, Thomas. So, I think one takeaway very quickly I can say from what you just mentioned was that we have to convince people that heat pumps work, right? And I think that is something that has possibly, caused a bit of delay in the adoption everywhere of heat pumps. And I think, when we think about the 4 panelists we have here today, one is from Scotland, one is from the Netherlands, one is from Malta, and one is from Italy. You couldn't think of a more broader geographical spread, and also, different cultural spread as well. So the fact that we can make these things work in this kind of geography hopefully helps the audience understand that this is a technology for everywhere, not just one particular region of the world. So I'm going to start off here with, kick off here with Donald, who has got a very interesting project in Scotland. So maybe, Donald, you can tell us a little bit about the background of your project, because it's quite an exciting one, actually.
Sure, Jose. Yeah, the project is a collaboration between ourselves and the local municipality, Stirling Council, and we have created an energy centre on our wastewater treatment plant using a mixture of different technologies. So we have Trane heat pumps recovering heat from the wastewater. We have combined heat and power, and we also have biogas boilers because the wastewater treatment plant hosts anaerobic digestion as part of our treatment process. And in the project, what we've done effectively is we've had a collaboration with us, as I've said, with the council, and we wholesale the heat from our energy centre to the council, and they then distribute that heat out to a number of municipal buildings and offices in the area. So they've created a brand new district heat network to take our heat. It's about 2.5 kilometres long, and that heat network is seen as basically the start of something that will grow over time as demand for the heat increases and more customers sign up to take the heat on the network. So initially it's connecting up a high school, a leisure centre. The leisure centre has a gymnasium, an ice rink, swimming pool, a football stadium, and as I said, various offices nearby.
Yeah, we're seeing some great pictures here of the installation on the screen. So maybe you could tell us a little bit about, before this project went online, how would a lot of this heat have been produced in this area in Scotland?
Yeah, all of the connected premises are the alternative for them really is natural gas through the mains gas network. Some of the offices that have been connected are actually, it's a refurbished army barracks that has been repurposed into offices. So their alternative would have been to take natural gas through boilers. But as this project came online, they became aware of our project, and they didn't bother putting in any natural gas boilers. They've actually said, no, we'll take the district heat from the network and we'll use that. Some of the other connected premises, such as the high school, the leisure centre, the football stadium, they were taking natural gas through the network already. So we've displaced natural gas by doing this project.
Yeah, that's amazing, right? And when you think about where you're taking the heat from, something that is considered, as Geraldine said earlier, waste, right? It's we're recycling this waste to get this heat. And I know that you've done some calculations on how much CO2 emissions you think or you are avoiding by doing this. Maybe you can share that with the audience.
Yeah, just on this first phase, as I've said, we anticipate that the scheme will grow, but on the first phase, we calculate it will save about 381 tonnes of CO2 every year. And the beauty of what we've got there is we're only using a very, very small proportion of the wastewater that's available. So we have much more potential to grow this project as the demand in the network grows. You know, we can extract a lot more heat without impacting the process at all.
Yeah, that's amazing. You know, I'm very glad because 380 tons times 10 is 3,800 tons, and you know, I can subtract that from the gigaton that we have to do by 2030. So it all, you know, there's the old saying: if you take care of the pennies, the dollars look after themselves, right? So it's very well done.
Helps.
Yes. So Thomas, do you have any? Maybe you can ask a few questions here. I know that you have some. Thomas, I think you're on mute.
Donald, thank you very much. That was very interesting. As you say that you have much more potential, do you have any plans to extend the grid? And as a second question that I didn't hear, do you also use the cooling of the heat pump? So are you using both services?
So on the first question, the council is looking at connecting more premises at the moment. So the plan is to extend the network, but beyond the Stirling Council area, we are also working on other projects doing exactly this. So we have a project near Glasgow Airport where we're looking at taking again the heat from the wastewater, and this time using the wastewater heat in an ambient loop and boosting the heat to building temperatures at the buildings. So that one will be a first in Scotland, and that particular project will look at heating and cooling in the ambient loop. On our project in Stirling, it's purely heating. It doesn't use the cooling function. It's estimated in Scotland that about 50% of our emissions as a country come from heating and cooling, and given the nature of our climate, most of that's on heating. If you see behind me today, there's a snow scene behind me. You know, it's pretty cold today.
I was wondering if you had a very nice background picture, but now that you say it is snowing.
Yeah.
But I mean, the typical Scottish climate would be absolutely welcoming for heat pumps, right? It's normally not below zero too much. So you could say Scotland, of many regions in Europe, is perfectly suited to be heated by heat pumps with a very, very high efficiency.
Well, we see that as the real beauty of what we are doing with the wastewater, because wastewater at the treatment plant where we take it from in Stirling or in the network, it's pretty consistent year round. So you know, if you look at a traditional water source heat pump from say a lake or a river, it's quite cold in the wintertime when you need that most. Whereas taking the wastewater, it's a nice consistent temperature all year round, and the efficiencies of the heat pump are higher as a result of that. Also, the beauty of what we're doing on the network, if you take the heat from the network, you can almost treat that like a district heat network in itself. Yeah. We can get the source of the wastewater and the source of the heat for the heat pumps quite close to the source of demand for the energy. You know, if we look at our network and extract the heat from the network rather than taking it downstream at the treatment process. Do
we have time for one more question, Jose? Or
of course, go ahead, Thomas. Yes.
And that's really about multiplication. We are working a lot with other bodies, Energy Cities, for example, the Covenant of Mayors. Are you at all in contact with other municipalities that could benefit from this type of solution? Because I know many of them are in the process of renovating their cities, making them more livable, working towards better air, cleaner air, and heat pumps would serve them quite well. But at the same time, they are often very skeptical about the technology. So are you working on that multiplication of your experience?
Yeah. As I mentioned, we've got a project near Glasgow, but we've also got projects in other cities and towns in Scotland that we're looking at. Quite a good one in Edinburgh at the moment that we're looking at. I agree with what you're saying, that people are often skeptical, and it does take a little bit of time for them to get their head into, oh, this is using wastewater, and I'm not quite sure about the technology. the simplest thing we try to say to them is, look, you've all got a heat pump in your house. You just know it as your refrigerator, and that's the simplest we try to describe the technology to them. We're also linked into a European project that is looking at different jurisdictions across Europe for heat pumps. Despite Brexit, we're still involved in these things.
Yeah.
Well, thank you, Donald, and we'll get back to you at during the Q&A. But you said something very striking there, that we all have a heat pump in our house called a refrigerator. I'd never thought of it that way. It's very true. I will reuse that one. And in fact, to introduce my next project, I'm going to steal shamelessly from Thomas. He mentioned to me once that the concept of thermal pollution, right? That we all know, when we think about pollution, we think about, emissions coming out of tailpipes of cars or, burning wood or whatever. But there is also a lot of thermal pollution going on where we just, let heat out into the atmosphere. And I thought that was a great thing that Thomas came up with there. And this next project from the Netherlands that Jeroen is going to talk about is really a project where they're trying to reduce thermal pollution and with heat pumps, and I won't say anything more, but Jeroen, maybe you can introduce your project.
Yes, thank you very much, Jose, because I think it's a very important project from the Netherlands. As a consultant, we were asked by the municipality to research different possibilities to make this area gas-free, because that's an ambition of the municipality for 2040, to make the complete area energy neutral. And we started to look at different sources for energy in this area. And we have found a data center emitting a lot of thermal energy to the air. We are speaking about 4 megawatts of excess heat. And we have tried to connect, and succeeded, we have tried to connect this data center to 3 other participants. A plant trading company, a leisure center, with a swimming pool, including a sports center, and a new built school. It was not very easy. We have worked 5 years at this project. We have coped with several challenges. We have found solutions, but now it's running. It's a project, I think, about 800 kilowatts. As you see some pictures now, you see also the layout of the network. We have built the network. It's about 1,400 meters, and most of it is made by HDD, horizontal directed drilling, which is an important technique, I think, in combination with the heat pumps, because it allows to distribute water from low temperatures, and we are speaking about the 22 degrees for the supply and 12 degrees for the return flow. So I think these are the most important highlights of the project. The pumps are installed at the data center. You can see it at this moment on the picture. We have indicated the supply tube with red and the return tube with blue, so that visitors can see how it works in practice.
Okay, Jeroen, well, that's a great introduction, and it's quite a sophisticated project, this one. I've obviously spent some time looking at it, but hopefully the people on the call with the map that was shown and then some of the pieces of equipment that involved, there's several stakeholders here, and it's a fairly big, let's say, construction project as well, because you have to dig a lot of pipe and then all the mechanics and control of all this. So, and my first question really is, how did you convince everybody to do this, right? Because it's not a very simple plug and play thing, right?
Now we had some very enthusiastic participants working at the sports center. and working at the data center. And these people were very persistent in their goal to make use of the excess heat of the data center, because it's existing. So you can do something with it, or you cannot do something with it, but it is emitted all the time, whole year round. And the technical employee of the sports center, he wanted to eliminate the combined heat power generator set. It was powered by natural gas, producing heat and power, so it's a good way of using natural gas. But his dream was to make this complete sports center natural gas free. So he kept on being very enthusiastic about the project, and that helped us to overcome the different challenges we had.
Yeah, and I have to say that this is quite a big dream, right? Because in the end, you may share with the audience, there is no more gas being used for heating here, right? If I'm correct.
And another dream was the school, because there's the new generation is raising up there, and the people from the school were very interested to take this technical project into the lessons, because they think the children are using their mobile phones, etc., using data, and what's more interesting than to be able to tell that the data processed in the data center is also resulting in heat for their school building. So that's another important thing I think we should mention.
Yes, this is a great example of challenging. In our company we have a new phrase that we've created around what we call challenge possible, right? And if the way you're describing this with the passion you're describing it, if you were to go at the very beginning where nothing had been done yet, and then you describe this end state, it's almost an impossible sort of dream, right? Or an impossible thing to do. But you guys challenged possible and you made it happen, and you're saving almost 400 tons of CO2 a year, which again is going to help us for the Gigaton challenge, but more importantly, help in decarbonizing the planet. So maybe Thomas, you can chip in here a little.
Yeah, I'm really enjoying my here, because it's these examples that I think need to be known much more. And Jérôme, I think you mentioned very aptly the importance of personal conviction. And you said that a number of people were so convinced that this should happen that they pushed forward, and that made it in the end easier. What I also hear, and that's of course, in first that's something that I like a lot, is that the Dutch government has announced that many areas of the Netherlands are supposed to become gas-free. But of course, there is the incumbents, and I would like to touch upon that, and maybe you can answer or can give me an insight from your perspective. How can we integrate the beneficiaries of today's situation? Because you said we replace CHP, replace gas boilers, so that makes a lot of people also unhappy, not because they're bad people, but simply because it's their livelihood that depends on it. And wouldn't it be much easier if we could convince them that there is also an economic and personal development future in more heat pumps? Is that something that you're touching upon? Is how do you integrate the people that are losing at the moment, or perceived to be losing?
Yes, it starts with knowledge about the possibilities. So I think a lot of people do not know that it is rather easy to heat and to cool your building with heat pumps. So we started with telling about the possibilities, about the economics, about the advantages of heat pumps. And there's also one threat in the Netherlands, and that is that the municipality will have the right in the future to eliminate natural gas from certain areas. So that's people know that, and I think more and more people like to be prepared for that situation.
Mm-hmm.
So yeah, I think we need different triggers. The financials are one, but maybe the possibility in the future to use natural gas is also very important.
And if you say that you're teaching the children already, I think this is another very important point. Do you recognize that children are actually questioning the status quo because they know that it's possible to do things differently?
Mm-hmm. Yeah, yes, I think this showcase is very important in that sense, because the proof of the pudding is in the eating. So I think you can see it here. You can see it here working.
One last question, a bit on the fun side. There is this 11 city tour in the Netherlands that hasn't been taking place for many years. You know, the skating tour. Do you think you could freeze over a channel by putting one of your horizontal direct drilling pipes below or more, and thus help the 11 city tour to come back to the Netherlands?
Yes, this is another area of the Netherlands, of course. Maybe it helps, and maybe you can use heat pumps for that. I don't know. Our exchange network is very, very deep underground. Our pipelines are 25 meters below the how do you call that? Below zero. And that's a big advantage of the drilling technique we used. That it's very easy to dive under buildings or dive under objects like trees, etc. So I don't think the code will help us in that way.
Well, thank you, Thomas and Jeroen. That we'll come back for the Q&A. But Thomas, you know, I haven't talked to you about this in the past, but here at Trane, we do create a lot of ice for ice rinks in the Netherlands and in other places, and we do use heat pumps. But the biggest problem of an ice rink is to melt the ice, and we use the heat pump later to melt the ice. But on a more serious note, this project, you know, data centers linked with heating is a big deal. And you know, we have many large data center customers, and we know how much cooling they use. And we also know we have a lot of heating customers. The more we can bring these two people together, you know, the more we can, use a renewable, something that's wasted to do something renewable, which is great for the environment. So we're going to move a little bit further south now, and we're going to talk to Ramon, who is responsible for the Mater Dei Hospital in Malta, which is a fabulous project. So we've talked about a wastewater treatment plant, we've talked about a data center and a district heating plant, and now we're going to talk about a hospital, which is a very important part of our day-to-day life. And Ramon, maybe you can introduce your project.
Yes, so good morning. Basically, our hospital is the main hospital in Malta. It's the largest hospital. Has around 1,000 beds, but this hospital is not only about beds. We have 2 building blocks dedicated to pathology labs. We have a building block dedicated to medical school. We have an outpatients department. We have a radiology department. So it's more like a clinical or health village rather than a hospital. Actually, this heat recovery project started off as a part of a much larger project. In 2017, we were preparing to replace the old chillers. We were running 14 air-cooled chillers and 2 water-cooled that were commissioned back in 2003. So we prepared an open tender, a call for tender, for the supply, installation, and maintenance for these chillers for a period of 15 years. Actually, someone might ask, why do we have water-cooled chillers? Well, as per original design matter, they already had a heat recovery project, a heat recovery system. Actually, this heat recovery used the old water-cooled chillers to preheat the incoming cold water before going into the domestic cold water system. The chillers that we originally had, the water-cooled chillers, maximum condensing temperature of 50 degrees. So actually, as we all know, there's not much that you can do with 50 degrees Celsius. You have to tap, exchange heat with a lower source. We have the domestic cold water with degrees Celsius, and in summer is 23. So having a 50 degrees Celsius condensing temperature, we exchange heat by preheating the incoming domestic cold water. So actually, that was the main scope. We replaced 14 air-cooled chillers and 2 water-cooled chillers. Actually, we bought as well the third water-cooled chillers. But maybe we can explain later on then how we decided to change the design actually.
Yeah, I think you should go ahead with that. I think because it's, you know, I think your story is one around where you made a discovery that it is possible to have chillers that produce more than 50-degree water, and that changed your whole outlook on your project. So maybe you can tell that story.
Yeah, actually, we have a quite complex building management system here at Mater Dei, which permits me to monitor the incoming flows and temperatures, so I can optimize parameters. And I can estimate, even by going back to designs, where the real opportunities are. And I've been noticing for quite a long time that there was a great opportunity if we could recover heat and exchange it with the HVAC system, with the heating for the HVAC system. Unfortunately, when I discuss with people in general, they tend to associate heating with winter and cooling with summer. But it's not the case in this hospital, because we put a lot of outside air into this hospital, because we need a lot of air changes. All systems are all outside air, full fresh air. And it can get pretty humid in the summer months in Malta. I mean, for those technical and familiar with HVAC, I mean, to have a dew point of 23 degrees Celsius is very common, something which is normal. So before putting in outside air, you have to dehumidify. So basically in this hospital, we have heat load all throughout the year, even in summer. In fact, I have graphs, I presented graphs that see peak loads for heating in July and even in December, or maybe sometimes even in September. So heat load is associated as well with the summer months. So basically, I'm coming back now, how this came to be. Actually, FM Core Limited, which is the company who won the bid for this tender, we were discussing on when we were preparing to order the water-cooled chillers, and we were discussing this, and we were explaining why we need the water-cooled chillers. And actually, I explained my idea, I mean, my observations that I had, and I explained that if only we could find a product that permits us to exchange heat with a return temperature of 50 degrees, I mean, that would be something better than we had actually. And that's how FM Core went back to Trane to see their line of products. And they came back with the RTWF chillers with a condensing temperature of 68 degrees. And obviously that changed the whole scenario now, because we can exchange heat from 68, with the 50 returning from the HVAC system. Obviously, we had to redo our system because previously we had heat exchange being exchanged with the domestic hot water. Now we're implementing this on the HVAC as well. Fortunately, I had a backup plate heat exchanger, which I redesigned and installed in the system. We did a few modifications on the piping, and actually we implemented this project.
It's a fabulous project. Maybe, Ramon, you can share with the audience, because it's very exciting, how much fuel oil and CO2 emissions you're avoiding every year in Malta there in Malta. Which, some beautiful pictures there coming through on the screen as we speak.
Yeah, yes, definitely, Jose. Actually, we're saving. I have just lately got the results for the year 2020. We saved 1 million liters of heating fuel,
Wow.
which equates to almost 2,700 in CO2 emissions. That's for the year 2020. Up till now, we have already saved 1.4 million liters of fuel, and that equates to around 3,800 tons of CO2. Just for a comparison, because it would be much more easier for that, we used to buy between 1.7 million and 1.8 million liters of fuel annually. For 2020, we only bought about 700,000 liters. So it's much more than 50% savings in fuel.
Yeah, that's an amazing. It's incredible how much fuel you're avoiding burning, and that's, as you said, all CO2 that doesn't go into the atmosphere. And when we talk in Trane Technologies about challenging an industry, this is another great example that if every hospital did like your hospital, Ramon, it would be, starting to have an impact on the planet, right? So, it's great leadership and great savings, and it's a fantastic project. And maybe I'll let Thomas here say a few words and ask some questions.
Yeah, now you may think I'm a bit obsessed with this multiplication, and indeed I am. Ramon, I think this is a delight to see this project. And what I hear from what you said is that it was also a bit your insistence and your knowledge that led to finding the solution that eventually was used. Do you think that in your profession, in mechanical engineers, in electric engineers, do we have enough knowledge to question the original system designs and to introduce new solutions?
Well, definitely the knowledge is there. What sometimes is missing, and if it wasn't for the help for our contractor and for Trane, sometimes we're not up to date with the latest products available on the market. That is something which I was not aware, and that is with the help of our contractor, and I wasn't aware that Trane was producing a chiller with a condensing temperature of 68 degrees. So actually, it's not the technical knowledge that it's missing. It's rather, and there's a reason for that, because now I've heard that Trane came up with a chiller heat pump with 80 degrees Celsius.
Yeah.
So these things are progressing very fast, and sometimes you have to keep up. Sometimes you have to be in as how they say, at the right moment, at the right place at the right moment. So to reap the opportunity. So it's not a question of engineers not having the technical knowledge, but rather the what's on the market is really going really fast. That's why that.
So that's very interesting. So it's a question of transparency. Then I would ask you, where do you get your knowledge from? If we think from the outside and we would like to tell the story that you have told us today to another hospital operator, how would they get the information about this? I assume everybody is very busy. Where do you get your news from?
Actually, I keep myself up to date with the mostly European forums, European associations. I research on things. Well, some things. I mean, for example, as I led latest, as I said, latest. You're not always up to date with the latest technologies available on the market. But I think a lesson learned from this project is this: something which was designed 13, 14 years ago, it's not necessarily still valid for today, which is, I am sure that the system is the way it is because the technology was not available back then. But this does not mean that the technology right now doesn't permit you to do something which is better. And something which is very important to take note of is that this, as I said, this was a project for replacing old equipment. And you know, we all replace equipment at home. We just but when we come to complex situations like this, it's not something that you put away an old product and you just buy the new. You have to think about the design as well. Redesign, for example, a redesign was for this to work. I mean, definitely, it's not something that you put away the old and buy with the new. So the one lesson learned from this project is to rethink the designs. When you have the opportunity to replace equipment, rather than looking out for new equipment, you have to think about redesigning as well. The opportunity for redesigning for higher efficiency.
Super. Then I take the opportunity to tell everybody that the heat pumps now can actually, on the industrial scale, even provide 160 degrees Celsius. So as you say, the progress is going very fast. I've been talking to some of the researchers. They say, well, 200 degrees is possible. We don't know when, but physically it's not out of range. So let's be optimistic that more solutions will be there that can be used with the engineering knowledge that you provide. Thank you.
Thank you.
Thank you, Thomas, and thank you, Ramon. Some very, interesting topics coming out there. I wish we had more time to, delve in all of those. But I think this whole concept of building awareness that technologies exist and that technologies are getting better is critical in this transition. And I think this event is part of, trying to do that, but it's a tiny thing, and hopefully we have to spread this knowledge as we go forward. Now, we've been to Scotland, we've been to Netherlands, we've been to Malta here now, and, at the hospital. We're going to finish off with, let's say, in Italy, in a very nice hotel where we can all relax. And Valerio is a man who's always up to date with the latest technologies. He's going to present the project here, a hotel project. It's a very famous hotel, and I'll let him speak about it.
Thanks, Jose, for the fantastic introduction. And first of all, let me thank again all the audience and our sales engineer, Fabio Ritucci, that handled the project, and our client, Mr. Cometto, that is here with us, and he is the owner of the hotel, and on whose behalf I'm speaking. So the hotel, first of all, the Hotel Excelsior is in Rapallo, is a 5-star resort in a fantastic point just in front of the sea, as you can see. It is on Portofino's coast, and it features 120 rooms, a conference center, some suites, a wellness center, and a heated pool. It is, by the way, an historical building erected at the beginning of 20th century. And in 2019, the owner decided to substitute the water-cooled cooling-only chillers and the associated towers with new units in order to make the hotel more sustainable. Of course, the idea was to save electricity consumption and reduce the carbon footprint. Mainly through boiler displacement. because boilers were used for heating and the chillers just for cooling without any heat recovery, let's say. So I would like to let Mr. Cometto comment about the main targets that they said they had when they started the project, so that he can explain us which was their target before starting the project. I don't know.
Yes. Hello, everybody. First of all, I wanted to thank Trane for the work, for the job. We decided to invest in the replacement of the heating and air conditioning system for a number of reasons. First of all, to replace the old systems. They had 20 years old, and so we wanted to save energy and less carbon dioxide emission, because the system was very old. And the last reason was to free and to recuperate space in the top of the building, where there were the old system, because we wanted to use that place to make a rooftop for our guests. And we ended the work last year, and now we will open the rooftop in this summer season. And so I think that the project was correct and perfect for the hotel, for the save of energy, and to use the space for the rooftop.
Thank you. So I would say that thanks to this, let's say, as Ramon said at the end of the story, when new technologies are to be used, it's worthwhile, redesigning the whole system with a kind of holistic approach. Probably when the hotel was built, or when the water-cooled units have been fitted, heat recovery was not so important topic, or probably was not possible. Now technology is there, and was worthwhile using the new technology to get multiple fruits at the end with the same seed, because they got energy efficiency, they got a smaller carbon footprint, they managed to free space to build other suites or meeting rooms or whatever, even business-wise for the hotel. Really an interesting move that is bringing fruits. And together with that, they got rid of the cooling towers, saving water as well. And they got rid of the noise, let's say, coming from the cooling towers. So multiple fruits from the same seed.
Yes, well, it's a fabulous project, and thank you, Mr. Cometto, for the order. You don't need to thank Trane. Thank you for trusting us with your hotel, right? It's a hotel with a lot of history, and a lot of famous people have visited the hotel, and I'm sure everybody on this call will want to go there one day after seeing that video. What I liked about this story, Valerio, is, as you mentioned, that sometimes people see a heat pump investment as, okay, it's going to help the environment, but it's going to cost me money, more than just burning the boiler, the gas through the fossil fuel boiler. But here we're seeing that converting away from a boiler plant, chiller plant, to a combined heating and cooling plant has given real savings, right? Real energy savings, which means operational savings, which I assume are very important for the hotel, but also opened up some floor space to create more rooms, if I recall correctly.
Correct.
So it's a win-win.
Correct.
So you can't ask for a better project than that, right? And if we can find more of these win-win type situations, I think we can accelerate this transition. So before we go to the Q&A, maybe I'll let Thomas, probe a little bit here for this hotel job, Thomas.
Yeah, one question that interests me, do you get positive feedback from your guests? Do they appreciate that you actually made a move, not only providing the most luxury and perfect comfort for them, but also doing that in an environmentally conscious way? Is that something, do you see demand for your move from an environmental perspective?
Sure, we said and we are saying to our guests the investment because we want to have an imagine of energy saving hotel, and so they are happy to this. And ensure the investment was also correct to improve the comfort of the guest in sense of noise, because the old system were in the top up the best suites, and so we improve the comfort and in free space, and we built a new penthouse and a new space for a bar, for a sky bar for the guests. So we are very happy to the investment, and so perfect for us.
Yeah, that's very good to hear. And when I look at it from the perspective of other hotel owners and operators, do they come to you and say, "Hey, what did you do there? Does it work?" Are you a role model now in the hotel owner and operators group in Malta?
I didn't hear. Sorry.
Do you get positive recognition with other hotel owners in Malta?
In Italy.
Sorry, no, yeah.
Okay, in Italy. No, we sponsored in the territory the investor, because we had flag the project, and we sponsor to the hotel, because the hotel the Excelsior is the first hotel in the zone, and so we tried to speak also to the owner of the zone of hotels to follow us to save energy and invest in that sense.
Mm-hmm. Okay. Well, thank you very much.
Thank you, Valerio and Mr. Comerto. And so I'm going to pass it over here to Geraldine, who's going to facilitate the Q&A before we close out for today. But a lot of exciting things said so far, Geraldine.
Yeah, absolutely. It's been great to hear from all of the projects, and especially great that we were able to put this together in a virtual way. You know, we hoped initially that we could meet face to face, and then we changed our plan to virtual when we knew that would be the safer way to do it. So it's great that we were able to get here today. Some really interesting questions coming through. So I'm going to start with the first one, and this would be for you, Jose. The question is, has Trane done any heat pump project in the pharmaceutical industry? And also, is there any application which could replace a steam heat exchanger?
Yes, I don't have any coming to the top of my mind, but I think what I can say is that we're trying to, or we're not trying, but we are actively pursuing in every country in Europe and beyond, that wherever we see, obviously we're very strong in cooling plants, but we're also starting to ask our customers questions around how they're generating their heat. And one of the key, let's say, strategic programs we have is around combining heating and cooling, because if we can combine heating and cooling plants, there are a lot of benefits from an energy point of view. So you can move, the most efficient, let's say, separated cooling and heating plants can, for every unit of energy you put in, you're going to get possibly 2 to 3 units of cooling and heating out. When you combine a heating and cooling plant, you can increase that efficiency to 6 or 7 or above sometimes. So, from a pharmaceutical perspective, none come to mind, but I can ask some of my sales leaders and come back and answer that question more.
Yeah, and maybe just to add to that, Jose, obviously the pharmaceutical industry is very important for our overall enterprise when we think about Trane Technologies and our Thermo King brand, the refrigerated transportation and storage. So we do work very broadly in the pharmaceutical industry. So indeed, happy to take that question outside of this session further. I have the name of the person who's asked it, so we can connect with them. So the next question I'll go back to the top. We got a long list of questions coming in as some of the speakers were speaking. And the first one actually that came in as Donald was speaking about the Scottish Water Horizons project was, what was the wastewater temperature average? Donald, if you could answer that.
Yeah, it typically varies between 8 degrees and 15 degrees, depending on rainfall. So rainfall in the catchment of the wastewater plant has the effect of diluting down the temperature in the wastewater.
Thank you, Donald. And then we had one coming in for Jeroen for the Aalsmeer hub project in the Netherlands. So what is the typical supply temperature of the heating water?
The typical supply temperature is 22 degrees Celsius. That's the temperature of the excess heat from the data center. Maybe a small addition to my presentation. We also had a redesign question at the sports center, because the gas-fired installations, they used to be operated at 80 degrees Celsius. We now know from Thomas that it's possible to purchase heat pumps for this temperature, but we have tried to lower the temperature in the sports center, especially for the showers, to 55 degrees Celsius. We have done a stress test before with the gas-fired installation to examine what parts of the gas installation or the original installation should be changed to make it suitable for the heat pumps. And we have succeeded in doing this. So I think it's important to mention this, because in the other projects also a redesigning question was raised. So I have also one.
Yeah, thanks so much, Jeroen, for mentioning that. Another question came in for the Scotland project. So for Donald, does wastewater mean water that is coming out from the water treatment plant before being delivered to the river? And then what is the average temperature of the water inlet to the heat pump systems?
Yeah, the wastewater is, we're extracting the heat from the wastewater as it arrives from the pipes from the city before it gets treated. And it's the same answer as previously, really, on between 8 and 15 degrees C. The project I mentioned in near Glasgow Airport, that's different. That's going to take the heat from the wastewater after it's treated, but just before it's discharged into the river.
That's great. Thank you, Donald. And again, seems to be popular questions coming in also for the Netherlands project. Although, Jeroen, I think you've covered this to a certain extent, just bear with me. So yeah, there's two parts to this question. What are the hot water temperatures? I understood the cooling side for the data center works at 12 or 22 degrees Celsius. And then another part of that question was, has the leisure centre got a backup system? Let me know if you'd like me to repeat any part of that, Jeroen.
Oh, there's no backup system at the sports leisure centre. It has been an important question in the project. Should we have a backup system? Because when the data center goes down, the leisure centre has no heat. It's also the case for the plant company and also for the school. We have discussed this this question very deeply, and we came to the conclusion that in the business case there was no room for example, an aquifer storage, and we don't need it because we also don't need it because the data center is a very valuable source of heat. The uptime is very, very high, so it's a very good heat source. So we have no storage.
Thank you very much, Jeroen. I'd also like to invite anyone else that still has questions to continue to submit them through the chat box function. And I'm just going to scroll down and see what else might be coming through. Yes. So again, for the Netherlands, we have a question. Could you better explain how the system works? Is it correct to summarize that the Trane system is cooling down the data center and the heat is delivered to the district grid? And then there's another part to the question, what happens when the heating season is over? And what is the role of the ground horizontal heat exchanger?
Trying to remember the question. The Trane heat pumps are installed in the leisure center, so they heat the swimming pool and the sports hall. So they cool down the 22 degrees from the data center to 12 degrees, and then they return the cold to the data center. So, and that's a way for the data center to cool partially. So that's the Trane heat pumps are for heating. And the other question was?
So let me, just go back and read the second part of the question. So what happens when the heating season is over and what is the role of the ground horizontal exchanger? And then the other part with the piece I think you did explain about how the system works.
Yeah. For the swimming pool, the heating season is whole of the year. So there of course there's a dip for space heating, but they at every moment of the year they have a heat demand. So the system is running the whole year. In the cooling season, the school is dumping excess heat on the system, and it can be used by the swimming pool. So there's a horizontal exchange the whole year round.
That's great. Thank you, Jeroen. There's then another interesting question, which is actually for two of the projects for the hospital and hotel. So the question is, how important was the isolation of vibration or reduction of structure-borne noise, especially in the critical projects of a hospital or luxury hotel? So how important was the isolation of vibration or reduction of structure-borne noise? Raymond, do you want to talk about that for the hospital?
Yes, sure. Practically, I've had chillers, not only here in hospital and even in a previous company. All Trane chillers, and even the chillers we had here, which we were not Trane, have these very stiff rubber mounts. And actually, neither where I used to wear, neither here I experience vibrations to the structures. Maybe someone from Trane can elaborate on this, but basically there's nothing special, nothing about this. I mean, it's something which comes with the chiller. You mount the feet on. We had not even on the previous chillers. We didn't have any particular designs to go about avoiding these vibrations. You know.
So if I hear you correctly, Raymond, it wasn't an issue for the project. It wasn't.
No.
It didn't become an issue in that sense. No,
it wasn't an issue with the previous chillers, and it wasn't an issue with these as well. Mm-hmm. I mean, I don't know. I don't think I get the impression that these rotary helical compressors do not necessarily generate too much vibrations on the structure itself.
And Jose, I guess in a sense, this question might also be a little related to the whole topic that we're looking at Trane Technologies in terms of indoor environmental quality. Is there anything you want to add in response to that question?
No, I think there was two things asked there around vibrations and around sound, and maybe we heard a little bit about from the Excelsior Excelsior Hotel, I apologize, that sound actually was a big consideration for them. Maybe Valerio, you can touch on that again.
Yes, I would mind what Ramon said. At the end, we are talking about two different technologies. In the hospital, we have screw compressors, and in the hotel, scroll compressors that normally are used for heat pumps. Food. At the end, I would say that compressors are perfectly balanced, and the vibrations and noise ejected from the compressors are normally minimized. On top of that, the anti-vibration mounts are selected according to the frequencies of the compressor. So both vibrations and noise coming up from the units are minimized. And on top of that, let's say the installation in the hospital was into the technical room. So let's say noise and vibrations are reduced because the units are confined. In the hotel, the units are fitted in a kind of well that helped to free space. And let's say we used the best configurations in terms of noise reduction, so extra low noise configuration. So we expected to get lower noise than in the past that when, let's say, cooling towers were fitted.
Thank you very much, Valerio. Really good to get the insight also from the hotel environment. Some more questions coming through. So this question is it's directed towards all of the presenters, so we can choose maybe one or two people to share their views on it. And the question says, I'd like to extend to the presenters the question about end users' willingness to value environmental commitment and investment, also to the extent of spending some little more. So, I guess are the end users willing to invest and in some cases spend more? So maybe I'll just leave that open to the panel and see who would like to answer that question. Donald, I don't know if you, or Jeroen, go ahead, yeah.
Yes, I can tell something from the Netherlands about this question. We have discussed the business case very long for a long time because it was not a positive business case. The payback time was longer than the expected technical lifetime of the equipment. So we had a problem there. So the participants were not willing to invest in an unprofitable business case. So we have, for this project, we have asked for a subsidy from the government, and we got it. So that made it possible. And now we have a payback time of around 10 years, and that was acceptable for the participants. So I think the economics of it are also very important. The environmental aspect is important, but also the economics are important. And I believe that the price of this kind of projects will decrease as a result of doing these projects. Mm-hmm. Because we can share our experiences with others, and we can also the faults we made. So coming projects will be more attractive, I think, also in an economic way.
Yeah, and I definitely remember in our preparations, Jeroen, you talking about the importance of the relationship building and people really having that, genuine passion to want to make a difference to the planet and the world. So yes, the cost aspect is very important, but keeping the bigger, longer term, what are we going after is important. And maybe Donald, Donald, do you also want to say something? Because I know you're passionate about this piece as well.
Yeah, for us, it was actually very difficult on the Stirling project to make it, just like Jeroen's been saying, make it stack up economically. The project was supported by, as overall, it was just over £6 million investment. And within that, my organisation, Horizons, we invested £3 million. The local authority invested 1 million, Stirling Council, and the Scottish Government put in £2 million of a grant award to the project. The heat pumps in the UK currently also attract a subsidy, the renewable heat incentive. So without having the renewable heat incentive and without having the grant for from the Scottish Government, our project wouldn't have stacked up economically. And the challenge is to get projects that can stand on their own 2 feet at the moment, because gas is very, very cheap in the UK. On the other project I've mentioned near Glasgow, that one's different, because there's some pretty big public sector organisations there who are prepared to take a long-term view and are very keen to take a lower, significantly lower carbon impact by using the heat pumps from wastewater as their source of heat. And on that particular project, they are prepared to accept a heat tariff that is significantly higher than today's current price of gas. But at the moment, for us, the subsidy is extremely important, but it doesn't have long-term certainty from the UK government at the moment, so it's making things very difficult for us to get projects to be investable, because there's no long-term picture of what the economics look like.
Yeah, but it sounds like from what you said, the people involved in decision making saw the longer term value in terms of the impact for our environment and the planet. So that's good to hear.
Yeah, certainly on the project in Glasgow, that's absolutely been the case. They want the long term impact.
Another question, actually, Donald, has come in for you around. It's more of a statement, but you might want to respond to it. So the person has said, seems like some improvement could be done to separate the rainwater from the wastewater.
That is absolutely true, and it's absolutely the case that it's much simpler to do than to achieve. When you think it, so the project I've been talking about, if anyone knows the movie Braveheart, that's the area where that Stirling is the Braveheart area, if you like. Some of the infrastructure we have in these cities is literally hundreds of years old, and to separate rainwater from those kind of systems, it's the right thing to do, but it's quite often very difficult to achieve. Modern towns have the rainwater already separated, and we manage the rainwater in a much more sustainable way. But I'm afraid we're dealing with legacy and history with a lot of these older pieces of infrastructure, and we are trying to achieve that over the longer term.
Thanks very much, Donald. I'm conscious that we just have 5 minutes left and a few more questions have come through. This is an interesting one, and I think we will follow up later on it. So the question is, do we have any available teaching resources, such as PowerPoint presentations, that can be shared with us to disseminate information related with the employment of heat pump technology in various applications? So
yes.
Yes.
Yeah, we do, and we are strengthening that part of our organization. We have a part of our organization called Trane Academy, and we have, I'll discuss it with Anne, who's responsible for that and that team. But we are putting a lot of energy around training, building awareness internally, but we also, some of those materials could be used externally.
Mm-hmm. Yeah, and I think we can also consider it for any of our future roundtable sessions, how we might integrate some of that into the sessions. We may not get to all of the questions, and if you haven't heard your question being asked or answered, we will follow up with any of the unanswered questions to all of the participants. So one question came in related to, did we work at all with the electricity utility in the area? And if so, what was our involvement in any of the projects? So was there any work with the electricity utility? And I'm unaware if that was the case. So I'm not sure if anyone would want to respond to that one. And I guess if there's no response, it may mean that we didn't.
I'll take that one if you like, Geraldine.
Thanks.
For our projects, for any new demand, electrical demand using heat pumps using electrical demand, we always have to apply to the local electricity company to get a connection agreement for any new demand. So for example, we have a project using heat from a sewage pumping station in Argyll, and that required a new connection agreement with the local electricity company there.
Great. I've seen another request come through for the pharmaceutical industry, and that just to let that person know, John is his first name, that I will reach out. So he's asked for us to reach out together with the other person who asked the question earlier on pharmaceuticals. So we will follow up on that. Another question, going back to Thomas's question earlier, I'm not clear on how much of a part cooling is playing in these projects. Could anyone give some info on considerations that were made for cooling? And Jeroen, maybe for the Netherlands, you might like to answer that.
Yes, our main cooler is the data center, because the returning cold makes it possible to lower the electricity demand for the conventional coolers of the data center. So that's the most important cooling option we use. And the other one is at the school and the plant trading company. They can cool with their heat pumps and dump the excess heat on the exchange network. So there are 3 participants of the total of 4 who are making use of the cooling option.
Yeah, and I think also, Geraldine, if we look at Malta, the hospital, and Excelsior Hotel, this is a combined heating and cooling plant that is there, right? So cooling is very important. I guess the most important thing is to make sure that we try to combine the heating and cooling as much as possible, because removing this siloed approach to heating and cooling is what drives the efficiency and shortens paybacks and a lot of other things.
Yeah, so this whole concept of simultaneous heating and cooling,
yes,
which we have, thankfully, great solutions to offer around that. I'm just also at the same time as answering, reading the other questions that have come through. The person who asked the question earlier around end users and their concern about environment, he was saying he was meaning more customers. So are people generally willing to pay a little more for a better environment? And I think from what the panelists have said so far, the answer would be yes, is what we're seeing. Is there anyone that wants to expand on the answer to that question?
I would only say, Geraldine, that it's not always about paying more. Okay, I think that we saw with Excelsior Hotel and Malta that to get this kind of heating situation, they're not paying more than they needed to refurbish their energy plants, and they refurbished them in a different way. And in the end, that was actually cheaper than doing it the old way. That's what we heard from Valerio and Ramon. So there's going to be instances where there's more, but there's a lot of opportunity for where it's going to be less, and this is what we should be really driving to. And I think, as one of the speakers said, that as we do more projects, the whole cost of this is going to continue to drop, and these ones where today it may be more could become equal or less in the future.
Yeah, that's great. Thank you very much. One final question before we then go to close the session. We have run over just slightly, but the session is recorded, so anyone who's missed the end could always go back and have a sneak peek. For the hospital, Raymond, if you have an answer to this question, so what is the payback period for the investment versus the cost savings?
This is a little bit difficult to answer, because as Jose has said previously, this wasn't just a heat recovery project. We had to replace these chillers in a way. So actually, it wasn't something that we had to put an extra expense and we had to calculate how much can we recover in savings to pay back. So I mean, this is something we, together with these 3 water-cooled chillers, we had another 14 air-cooled chillers. So I mean, in this particular case, it wasn't solely a heat recovery project, so it would be difficult to say. But actually, I mean, one can deduct this from the. Obviously, I'm not going to give financial figures for this, but one can count this on 1 million liters of fuel, how much that would cost a year. So that would give you an estimate of.
Your answer makes sense, Raymond. Also, when you say that they were ready to be replaced anyway, so it was a requirement for the hospital. So thank you so much, and thank you to all of the speakers. I would love to hand over to Jose to close us out on this session. It's been great to connect with you all, and thank you very much. Jose, the final words are to you.
First of all, I want to thank again all the participants. Okay, it's not easy to give the time to do this. You all have your own day-to-day jobs, so I really appreciate it. I really want to thank you, Geraldine, and your team, for organizing all this. It's not an easy process, especially doing it online. And I think it's been, the fact that we've had so much engagement, so much questions shows that there's a real excitement for this topic. So thank you. So I want to finish with basically a very clear statement that says that for Trane Technologies and Trane, the future is now. Okay, we should not think that these concepts of combining heating and cooling or removing fossil fueled boilers is something that's going to happen in the future. It's happening now, and we have 4 examples here, but there are hundreds and thousands of other customers who are doing this with Trane in Europe and in other parts of the world. Our goal is to make this millions of customers, and as we do that, we're going to continue to see a reduction of CO2 emissions, and that's how we're going to change our industry, and that's how we're going to solve some of these big pressing problems surrounding climate change. So for Trane Technologies, electrification is a core strategy. You've heard about it in terms of heating and cooling, or heating in particular here. But when we think about our Thermo King business, which is a transport refrigeration business, there is also a lot of work being done on electrifying that business, and I just want to assure the audience that that is also happening. And also we are always looking at other innovations in trying to reduce energy consumption, whether it's increasing efficiency of our products, adding solar panels or other forms of renewable energy onto our products, in addition to what we've heard of today. So I really thank everyone again, and let's challenge possible, and let's go and reduce the CO2 emissions of the planet so that we can have a better climate for everyone in the future. Thank you.
Thank you, Jose. And with that, I will close us out with a small snapshot or reflection on today.